Hello friends, I'm Sheshadri Naik from COEPian Academy, and we're going to discuss the next study circle problem which was shared couple of days ago, and the problem is written here. It says that the two poles of height A and B are p meters apart. Prove that the height h of the point of intersection n of the lines joining the top of each pole with the foot of the opposite pole is AB upon A plus B, which is equals to H. This is what we want to prove. There's a diagram here. So carefully look at the diagram. It says that SA is the pole and the second pole is RB. So RB is of height A and SA is of height B. And what they're doing is they have connected S to B, and that particular line is seen here, and A to R. So that line is seen here. So this is A to R, and this is line S to B, and they intersect at point N, and H is the height of this particular point N. So Tn is equal to H, and they have given that AT is equal to X, and Ty is equal to TB is equal to Y. Now this is what we want to prove. So obviously this particular problem is based on similarity. There's no you will immediately come to know looking at the diagram that it is based on similarity of triangles. But there's one interesting thing about this particular interesting trick uh, about this particular problem is that too many variables. If you look at it, there's A, there's B, there's H, there's X, there's Y, and also there's P, which is given here. So there are too many variables. So what we need to do is the final answer, there's only H, A, and B. So obviously we need to eliminate X, Y, and P. So three variables are to be eliminated, and this is how we can prove it. So let's look at the solution. So in this particular figure, it says that P is equal to X plus Y. So X plus Y is equal to P. Now, in the triangles, in the two triangles, ABR and ATN. So ABR and ATN. So these particular triangles, they are similar, which is obvious because this particular angle is a right angle, and this angle A is common between them. So by AA test, these two triangles are similar. So because they are similar, what we can say is that AB upon AT, AB upon AT, AB upon AT is equal to BR. BR is this particular distance upon TN. TN is H. So if you substitute, AB is P, AT is X, BR is A, and Tn is equal to H. So this is the first equation. Now, as I told you that we need to eliminate variables. So let's try to eliminate X. So I'll write this X, this equation in terms of X is equal to PH upon A. So this is our first equation. So similarly, we can prove that triangles BTN and BAS, which is from the opposite side. So let me erase my previous drawing so that it is visible. So from the opposite side, if you look at it, again, there are similar triangles which you can see that this particular triangle BTN and BAS, they also will be similar because these two angles are 90 degrees and this angle B is a common angle between them. So by AA test, they will be similar. So based on that, what we can say is that BT upon BA is equal to Tn upon As. Now substituting the values of BT, BA, Tn, and As, what we get is that y upon P is equal to H upon B. Again, we want to eliminate y as we tried to eliminate x here. Let's try to make an equation using y. So y is equal to pH upon B. So these are the two equations that we got. Now we just simply need to add. Now what we can see is that x plus y, which is this x and this particular y. So x plus y is p. That is what we already know. Um, so if you substitute these two, so ph x was ph upon a and y was ph upon b. So if we substitute, this is what we get. Now from here, from the right hand side, we take pH as common. What remains is 1 upon A plus 1 upon B. Now if you take LCM here, what we get is AB in the denominator and B plus A in the numerator. So this is the equation. So P is equal to pH into bracket B plus A upon A plus B. Now we can safely eliminate P from both the sides. We can safely eliminate P from both the sides. So what we get is 1 is equal to H into bracket B plus A upon A plus B. Now if you take H on one side and the remaining terms on the other side, what we get is H is equal to AB upon A plus B. This is what we wanted to prove. So it's a simple proof. Only thing is it is based on similarity. The trick in this particular problem is that we need to eliminate certain variables, and these variables are x, y, and p. So these are the three variables that we eliminated, and we were able to prove that h is equal to a b upon a plus b. um, I hope you have understood. If you have any queries, you can get back to us. Thanks for watching. If you like this video, uh, like it and subscribe to our channel. Thank you.